Assalamualaikum warahmatullahi wabarakatuh. Welcome to Wisdom International School's digital classroom for mathematics. Children, we'll start a new chapter today. We are going to learn rational numbers. So already we have finished squares and square roots. So this is a very simple topic, but then it's the basics. Okay, you have to learn everything properly to solve more complicated problems in future. Okay, so first let's just look at one small revision we'll do. So you all are familiar with natural numbers, right? So the numbers which start from 1, see, right from our childhood we have been learning this number 1, 2, 3 and so on up to infinity. Okay, so these are natural numbers. Okay, so if I ask you, does 0 belong to this number, you will say that no, because natural number starts only from 1. Okay, so and it's denoted by capital N. Then you get a number called whole numbers. So here you have 0 also included. So 0, 1, 2, 3 and everything, all these are whole numbers. Okay, so W is given for this whole numbers. Okay, and if you have a number lesser than 0, that is negative 1, negative 2, negative 3, negative 4 and so on, all the numbers with negative sign and all the numbers with positive sign including the 0, all these are called as integers. Okay, so here the decimal number like 1.2, 3.5, all these are not integers. Okay, integer is a proper normal number without any a decimal point or a denominator. Okay, so these are integers, so that's denoted by Z. And then you have rational numbers. So rational numbers are, these are the numbers. Okay, 3 by 2, 4 by 5, 6 by 4. So you have a numerator, this is called as the numerator, and the one at the bottom is called as the denominator. So when you can write the number in this form, numerator divided by the denominator, then it is called as a rational number. Okay, so see, all the rational numbers are not integers. So if I ask you 3 by 2, is it an integer? It's not. Okay, but 4 by 1 is also an rational number because 4 has got a denominator of 1 over here. Okay, so if I can even write 4 by 1 as simply 4 also. Okay, so all the numbers like 1, 2, 3, 4, 5, whatever it is, okay, all these numbers have 1 in the denominator. Okay, which we don't have to actually specifically write it. So all the numbers which we have learned so far, like all the integers, are actually rational numbers. Okay, so 3, 4, 10 is a rational number because you can write 3 as 3 by 1, 4 as 4 by 1, 10 as 10 by 1 and so on. Okay, so any rational number is a number where you have a denominator and a numerator. So if I ask you what is the numerator and denominator of 3, you will say that the numerator is 3 and the denominator is simply 1. Okay, so here you see, rational number is a number which can be written in the form of P by Q. But remember, Q can be any number but not 0. Okay, so if you have a 0 in the denominator, then that particular number will be undefined. Okay, that number does not exist at all. So Q should not be 0, that is, the denominator should not be 0 in any case. Okay, so now we are going to learn some properties of rational numbers. So you understood what a rational number is, right? Okay, so now we'll see with the closure property. So when I say closure, what it actually means is, so I'll just give you a few examples, you'll understand it better. See, here you see whole numbers. Okay, you know what are whole numbers, right? Whole numbers are numbers like 0, 1, 2, 3, etc. right? So now addition, so if I ask you, is whole numbers, are the whole numbers do they satisfy this closure property in case of addition? See, what it means is, so let's say A and B are two whole numbers. Okay, then A plus B is also a whole number. So that is what you mean by a closure property of addition. Like if you take two numbers, any of the two whole numbers, you can take any number from 0, 1, 2 and so on, and if you try to add both the numbers, will that also give you a whole number? So if it gives, then you say that yes, it satisfies the closure property. So let's say A is something like, you can take any number, let's say 2, and B is, let's say, 10. Okay, then 2 plus 10 is equals to 12, and 12 is also a whole number. So this satisfies for all the numbers. So addition satisfies for the the whole number satisfy the closure property of addition. Now you see the subtraction. What happens in subtraction? Now if you look at A, let me take A to be 2 as I said, and let me take B to be 10. Then if I do 2 minus 10, I'm actually getting minus 8 because the larger number is having a negative sign, right? So that sign will be followed for this. So negative 8, that is minus 8, is not a whole number because whole number starts from 1, 2, 3, etc. So the numbers which are lesser than 1, negative 1, negative 2 and all, these don't belong to a whole number. So if A and B are whole numbers, then A minus B or B minus A. See, in this case, B minus A, 10 minus 2 is turning out to be a whole number. But 2 minus 10 is not a whole number, right? So we can't, say that, it's satisfying for all the conditions. So this need not be a whole number. Understood? So it doesn't satisfy the property of, closure property of subtraction. Now when it comes to multiplication, let me take A to be 2 again, B to be 10. So if I do A into 2, it's going to be 2 into A into B, which is 2 into 10, which is 20. And 20 is a whole number. So this satisfies. Now let's come to division. So if I take A to be 2 again and B to be 10, let us say, then A by B is going to be 2 by 10, which is actually 0.2. 0.2 is not a whole number. Whole number doesn't have a decimal point in it. Okay. So B by A satisfies. B by A gives you 10 by 2, which is 5. This works out, but A by B is not working out, so this doesn't satisfy. So what all satisfies? Addition and multiplication satisfies. Subtraction and division doesn't work out. So we say that whole numbers are closed under addition and multiplication, but is not closed under subtraction and division. Got it? So that's how you define the closure property. Now let's look at the integers. So we looked at the property of the closure property for whole numbers. Okay. Now we will look at the integers. So integers are numbers like you can have any number, any negative number. Let's say negative 3, negative 2, negative 1, 0, 1, 2, 3 and so on. Okay. So these are all integers. So now let us check what happens with the integers. Okay. So if I take two numbers, okay, two integer, let us take A and B again. A is equals to, let me take one negative number, negative 5, and B is equals to, let us take one positive number. Let me take negative, 3 or something. Okay. So now you see, is it closed under addition? I just have to check addition and see A plus B or B plus A, anything. Okay. A plus B is going to give you minus 5 plus 3, or B plus A is going to give you 3 minus 5. So both is going to give you negative 2, minus 2 as the answer, and minus 2 is again an integer only. So if you take any two integers, this integers, it's actually, when you add them, you are actually ending up getting an integer again. So integers are closed under addition. That's why I've written this. Okay. Now let's check at the subtraction. Okay. So let us take A to be minus 5 and B to be 3 as usual. Okay. So if I take A minus B or B minus A, I should see if I get an integer again. Okay. So A minus B is actually minus 5 minus 3, and B minus A will be, B is 3 minus A is minus 5, right? So I'll put a minus 5, minus of minus 5. So this is giving you minus 8 because the larger number is minus and it's minus minus, you are supposed to add, and here 3 plus 5 because minus into minus is plus, so you get 8. So in one case you are getting minus 8, in the other case you are getting plus 8. Both minus 8 and plus 8 belong to the integers only, right? So this is also, it's satisfying. Now let's come to multiplication. Okay. So if I take two numbers the same way, A equals to minus 5 and B equals to 3, let's multiply A into B or B into A. It's going to give you the same answer. Okay. So minus 5 into 3 is going to give you minus 15. So minus 15 is also an integer. Okay. So it's closed under multiplication also. Now let's look at the division part. Okay. Integers, what happens with the integers? I mean, with the when you're taking two integers, let us take minus 5 and B equals to 3, and you're dividing them. So if you do A by B, you are getting minus 5 by 3. It's not divisible, right? You're going to get a decimal answer. See, if you do 5 divided by 3, see, the minus is not a problem because all minus numbers also come under the integer category, but there should be a proper number, not a decimal answer, right? So here you will get minus. So let's divide 5 by 3 and see. 3 ones are 3, and then you get 2.0. 3 6 are 18. So you're getting 1.6, and then it goes on repeating. So you're getting a decimal answer. So decimal number is not called as a integer. Okay, so division is not closed under integers are not closed under division. So in this case, in case of integers, everything, addition, subtraction and multiplication, all the three work out, but division doesn't work out. Okay, so now I want you people to write the above properties in your classwork and understand it well and memorize them. Okay, Allah Hafiz. So we will see you with the next video. Allah Hafiz.